Good morning and welcome to this Mastering the Machine Automation Academy video for the 14th of May 2022. Today's topic was pneumatics from the fluid power section, document 3 of maintenance and troubleshooting in industrial automation. Hope you enjoy it. Good morning, folks, and welcome to this episode of Mastering the Machine for the 14th of May 2022. Today's topic is pneumatics. This is an extraction from my book, Maintenance and Troubleshooting in Industrial Automation. And I'll be doing a series of these over the next few months, barring any guests that I might have. A little bit about what this series is about. Automation NTH is a company that I do a couple weeks a month for developing materials, and they were kind enough to help sponsor this book. And so I put their logo on the front of the book, and they use this for their NTH University classes, which is mostly interns and young engineers who need to learn about different topics after graduating from college. So that's kind of where this logo came from. What is Mastering the Machine? This series is named after a document that I created in 2013, and you can download it at these two sites. And it's kind of evolved into a website that includes these webinars. So I do these every 2 weeks. Sometimes it's every 3 weeks, depending on my schedule, but I try to do them on a regular basis. And that is in support of this Automation Academy, which is a membership site. And I'll talk a little bit more about that and comparing it to the book here in a second. But anyway, it was named after Mastering the Machine, which is a guide to planning and machine building, which is the career field I've been in for most of my life. So that's kind of my background. What is the Automation Academy itself? I've put a bunch of training videos. I started creating PLC videos a couple of years ago. And I put some information, a job and aptitude assistance for people who are trying to either get into industrial automation or enhance their career. So there is some information on there from Ken Coleman's site connected with the Ramsey Solutions. And there's also a big library of training and technical documents and software. And I'm going to show you a little bit of that. And we're going to talk about exactly how you can get pieces of this book. This is my Automation Academy site, and you can see here there's a little splash screen. I update this about every week, just kind of say hello and things like that. And you can get into the different sections down here at the bottom. But in particular, in addition to the videos, which are here in the education section, there is a very large library, and the library contains information, as you can see, on a lot of different topics. But one of the topics is specifically my book. And so if you go in here, I've taken that book and separated into all these different documents. And this pretty much makes up the entire book, right? And then there's a lot of other information in here on Industry 4.0 and wiring and CAD and different things. But that's a little bit of a look at this. And so there is also a community with some interest groups, although that's kind of backed off lately. And I've extracted those parts of the book, and I've made individual documents out of them, as you can see. Now, a little bit about the book itself. The book has been released. It's a kind of a heavy book. It's kind of big and thick, and therefore it's expensive because it is all color. It's on good paper, that kind of stuff. So just the cost of printing the book, you know, is 20 or 30 bucks. And then by the time you mark it up several times, I don't set these prices. This is based on the cost of printing the book. And then buyers actually get this at 55% off of list. So list is 75, and then booksellers, all these booksellers here, Amazon, Barnes and Noble, things like that, get it at 45%, and then they mark it up from there. So the prices that you can see that people have set online here are these prices. So you can see the cheapest one here is 51 bucks, but I'm sure they also charge shipping. Even when I order my own books, I have to pay for shipping, even though the printer is right here in Nashville. I still have to pay for shipping. So can I get these books a little bit cheaper? Yes, I can. I get them for a little bit more than the 45% off, but I still have to pay for shipping. And then I also have to pay for shipping to anybody who were to order them. And it's a real pain to fulfill the books. So I don't even sell the books, although I have sold some, obviously, to Automation NTH and to their customers. And I give them even a discount off of what the booksellers pay. So enough about all of that. Today's topic is pneumatics. And it really comes from a section that is fluid power. I'll show you the document itself, kind of pull it over here. This is the document. I numbered these documents D01 through D24, and they are just PDFs. You can open them within the site and then save them to your laptop or whatever, and you would have the whole book. So that's a pretty good deal, considering that the Automation Academy you can get into for as cheap as $9.99 a month. And at $9.99 a month for 1 month, right, you can pull all those documents off of the site and you would have the whole book, which is the $75 list book. So this section is just part of the fluid power document within the book. And it's general information on pneumatics and hydraulics. And so fluid power is just a term that relates to both pneumatics and hydraulics. And in general, what it describes is actuators, valves, controlling the flow through the actuators, and then the air preparation, air handling. And I've got a few tips in there on troubleshooting these systems and things like that. So this is kind of this is all from the book. All these pictures are in the book. And you can see here, this is a general layout of one of the actuators. Pretty simple. I've got a whole bunch of these actuators that I'm going to show you at the end of this. I don't know if anybody can see my screen in here. Let me see. Actually, I see somebody's joined. Let me see if I can figure out how to display the videos here. Video settings. What I want to do is I want to be able to show, Matt, can you see me? I think you're on mute. But anyway, so what my intent would be is to be able to show, somebody's on chat. Yes. Okay. He can see me. Good. Okay. So, so anyway, what I've got here is I've got a whole bunch of actuators and air preparation and some valve banks and things that I'll show after I get done going through these slides. But in general, this is a cutaway of a typical cylinder. And what you can see here is air comes in the back end, it pushes against this face and pushes the rod out the front end. And then if you put air in the other end, it pushes against this face and it retracts it. Now, when you look at the formula for the amount of pressure that this can exert, you'll see that it's the surface area of this face. Well, from the back end, the surface area is a lot larger than from the front end, right? So if you put pressure in here, you're going to get less force retracting on this cylinder than you do extending from this side, right? Because it is a function of the size of the face. So typical actuator here, not so typical actuator here. This is one that is a gripper. I've got a little tiny gripper here. This is kind of cool. It's just, see if I can get it to retract. There we go. It doesn't move very much, but that's a little tiny gripper. It only has a stroke of that big, but it's got a mechanical setup inside of it. That's a couple of little gears, a rack and pinion. And so as you extend the cylinder, it turns this and moves this in and out, right? So pneumatic supply. And that's kind of how that works. So that's a not as typical type of air cylinder, but the general idea is still the same. The actuators are used to move or hold products or exert a force on something like a press, especially hydraulics. Typically, they're cylindrical. It's just a lot easier to seal a cylindrical surface. If you tried to use a square surface, you would have a hard time with all the gaskets and everything inside of the actuator itself. So that's why they make them round. It's just a lot easier to seal it than it is to seal the corners. So this is a typical valve manifold. I actually have a labeled, this is from the section in the book. Let me see if I can find the actual picture in here. You can see that I kind of labeled it and talked about the fact that these are the actual valves, right? And these screw into the manifold. And then this is a controller here. So this is a kind of a fancy valve bank that uses communications to link to all these valves, and then also has some auxiliary inputs. So that's kind of a cool kind of a valve bank because you can get inputs and outputs from it at the same time. So these are pretty common nowadays, where you have your communications to your IO instead of breaking things apart into multiple signals like this, right? This is a valve bank, and I'll show a closer up view of that. But you can see here, every single pin is exposed on this manifold. This is not a communications type manifold. Every single pin has voltage on it, and that actuates the valves themselves. So that is some of the components in here. One of the things that I put in the book, this was something that was confusing to me. I've always been pretty good at the control end, but when I first got into having to deal with pneumatics, you know, I noticed that there's little diagrams on the actuators or on the valves themselves, and I didn't know how to read them. And so it took me a while to figure that out. And I made this chart that allows people to read these diagrams. So the basic way to read these is, if you actuate one side of this, it will basically shift the diagram to that side. So if I were to actuate this side, then pressure would be on this, right, on the pressure port, and it would move to the B port, and then the A port would pass air back through here, right? You have two connections on your valves, and so your exhaust would come through here. If I actuate the other side, then it shifts to this side. And so where you see pressure here would be here, right? So the pressure would be on this port, and it would go to the A port, and then the B port would exhaust. So that's an easy way to kind of read this. And then there's different types of symbols that are on each end of this, you know, electrical or spring return type things here. That's what this is showing, return spring. This is a electrical solenoid actuator. Most of the time, these now are 24 volts. There are some 120 volt solenoids out there also, but most people use 24 volts for inputs and outputs nowadays in controls. So this is a view of some different types of valves. There's a 2-2 valve. So if I shift it to this side, it's just completely off. It blocks the port. If I shift it to this side, then it allows pressure to pass through it. I actually have one of those cylinders that you would use with that here. And in this case, you put air in here, and it's a spring return, right? And if you pass it to the other side, you would probably unplug the port and just let the air pass back through the valve, right? So that would be probably this 3-2 valve is something I would use with that. I don't remember which one I used on that actual valve bank back there, but this is from an old machine that got smashed up in a tornado. You can read more about that if you ever want to. I had a pretty cool machine in my shop, and a tornado went through the middle of the shop. And so I got a lot of the little pieces and things from that machine. But anyway, so this chart is somewhat useful, being able to read things. Here's an example of just a simple 5-3 valve, right? So if I actuate it to this side, it allows air to go into this port right here, and it will push the cylinder back against this face. And if I put air in through this side, if I actuate this cylinder, then air goes through this port and goes into this back end and extends the cylinder. So that's the basic idea behind reading those symbols. You do have to prepare air. And so this is just kind of a picture that I labeled air distribution block here. This is off of a machine, I believe at Automation NTH. It's got a manual shutoff on it. No, this is probably at ABD, because this is all in Spanish. and definitely ABD does things in Spanish. So this is just a typical air preparation unit here. You've got a lubricator in this case, which is not typical, right? You don't use lubricators on most newer systems. You don't need to have oil in your system to lubricate your actuators, but that was something that was done a long time ago pretty regularly. This is a combination filter regulator. I've got one of those here, and I'll show these a little bit closer later. This was a kind of a cool little device that I built for a leak tester. And so what you did is you applied air here on this side, and it would go into the leak tester, and there was a gauge here that would measure this, and there was a this is another gauge right here, right? This was a readout, and this was just a measurement tool. And then I actually put some of the valves on the back. And so what it would do is it would pressurize a closed chamber and do a simple leak test and just measure the decay. So it would close off the box, and then it would see how long it took for the air to escape from it. So that's a little mechanism that I built years ago. Some of the tips on adjustments and maintenance. These are some of the things that you would do as a typical maintenance person. You have to make sure that you've got good air going into the system. If you have dirty air, then your filters are going to get full and you're going to clog them up, and you might even destroy some of your actuators. So dry, if possible, right? As dry as possible. The filter does drain some of the water from the system, but obviously a little bit could make it through and do some damage to your actuators. So you want to make sure that you start out with good, clean, dry air. So there's usually some kind of a filter on the compressor itself, but as it makes its way through the plant, I do a lot of work in Miami, very humid down there, and a lot of water gets into the systems, even with all the filtering and everything that's in the plant. There's just a little bit of liquid in the system all the time. So you also need to drain these little cups right here, right? These things here, you can drain the water out at the bottom, and you can go look right in through this clear thing and see how much water has collected in your filter. And this is one that's kind of all together, right? This has everything internally, your filter and your regulator all together. Air preparation itself, set the pressure regulator to the pressure that you want to operate your machine at. You have to obviously have enough pressure going in to be able to set it to, say, 60 psi, 65 psi. You might have 80 psi coming in and then adjust it down to 65 or 70 or whatever you want to run it at to ensure, smooth operation of your devices. Check your filter bowls and drain them, clean them, all that kind of stuff. If lubricators are required, ensure that the oil reservoirs are filled with the proper lubricant. Again, we don't use lubricators on most systems nowadays. Actuators and control. There's an art to this, right? Periodically adjust your flow controls to ensure the proper movement of the cylinders and actuators. Faster is not always better. That's pretty much a blanket statement there. A lot of times you want to set it to something in between wide open and completely closed. I'm trying to look around here and see if I've got an example of a flow control. Here's one, right? So you can turn this little knob, and generally what you do is you meter out. You want to meter out for control, and that stops your cylinders from slamming when you first apply air. So that's a good control technique. What that means is that to adjust the downward speed, I want to take the outflow, right? And so this is on the output port right here of the cylinder. Now, of course, to adjust the speed going up, you're going to have another flow control on the other side, and that's the outflow of the air as you retract. So you've got two flow controls on there, and you're generally going to control them both. But to control the downward motion, you can basically open up the infeed and then restrict the outflow right here. And so metering out is generally, and that's on the actuating side, but you'll probably adjust both flow controls until you have a smooth motion. There's generally flow controls on both ports. Metering out is the best way to prevent the jerking movement of a cylinder that doesn't have anything on it, especially when you apply air to it. Check all your connections, fittings, hose connections for leaking air. You will definitely, when you first build a system, you'll hear a lot of air hissing out of various different points, and you want to make sure that everything's tight. This has a whole bunch of those little ports. These things are kind of hard to get at, and to pull these out, I have to push down this little lip right down here and then pull this out. And a lot of times you'll hear a hissing sound from this point. You want to make sure that things are kind of put in there tightly and that you don't have any air escaping from the system. You'll hear these on, on the actuators themselves, and you'll hear them on the valve banks and things like that. Just tighten everything up, make sure you're not losing any air. Also check for electrical connections. It's the same thing. You have individual solenoids, sometimes like this, and these have a special little wiring diagram on them. Usually it's 1, 2, and 3 pins, positive DC, 0 volt DC, and a ground. And in some cases, you definitely want to apply the ground. In other cases, it doesn't matter. Most of the 24 volt ones, I don't worry too much about ground because your negative DC is grounded anyway. When you're setting your sensors, a good tip here, do not set the sensor without any air on the machine, because if you do, you will have a slightly different position for the sensor than you do if you apply air. So there's a cushion at the bottom of these air solenoids, right? And a lot of times it moves a little bit. If I were to pull it down, I would be pushing against like a little rubber cushion. If I adjust this sensor with air on the machine, then I make sure that I'm centering it, right? I move it up and down. There's a little magnet inside of this, and I move the sensor up and down until it's kind of centered over the magnet in the extended position or in the retracted position, right? So usually you use something called a Hall effect sensor. People still call them proxies, but a Hall effect sensor senses a magnet inside of this. So all of these cylinders have little magnets inside of them. And then I mentioned here that more will be covered on sensors because there's another entire section of the book that is just on sensors, right? Hall effect sensors and proxies and photo eyes and that kind of thing. And the Hall effect sensors and proxies usually apply to your cylinders. Some other things that I mentioned in the book later, it's not really part of maintenance, but most of the time, if you were designing a system, you can put, cylinder proxies. That's the easiest thing to do, right? And I'm sensing the motion of the cylinder itself. But the other option, probably the more solid option, would be to check the position of the tooling itself rather than the cylinder. Because if something were to come loose, right, and this thing were retracting and extending, but this were stuck out, these little magnets have even been known to come loose sometimes. So if it's a really critical application, ideally you want to sense the position of the tooling, but that takes more wiring, right? And you can't stick your sensors in the little slots and things like that. This is one of the questions at the end of the document, right? And in the book, what does this cylinder do? So it's got 4 different solenoids here, and you kind of have to figure out what they all do here. Now this one, right, actually hits this actuator here. This is the actuator on one side of the valve. And so you can see here that it presses in and it would make this scenario come true, right? And so pressure would come in here and go to the A port. And then when I supply it and actuate this sensor, then it goes to the other side. So you can see there's 2 of those on here, valve 7 and 8. And then there's this, which is basically a sort of a toggling system here. And then this is the actual valve that controls the cylinder. So if you read through this, and I give the answer in the back of the book, but basically the idea behind this thing is it just toggles back and forth, right? This thing just shifts. It's just a cycling cylinder, but it takes all those valves to do that and to be able to electrically turn it off via this solenoid. So if I turn that cylinder off, then it moves over to this position and it exhausts and it just stays in the same position. I'm going to kind of shut this screen down and tell you the next webinar is May 28th. It's a couple weeks away, and I'm going to do a little show and tell here and make this screen go away so that people can see some of the devices that I'm holding up here a little closer. So let's see here, stop share. There we go. So now let's see. There we go. And I see Matt there too. And hopefully you can see my screen a little better. This was kind of a cool actuator that I just had sitting around. This is a rotary gripper, right? So you have two ports, one that rotates it one direction, one that rotates it the other. You can mechanically set this and make it stop so that if you don't want to rotate 180 degrees, you can rotate it, say 90 degrees. So you can set little pins in here and it will move just to a certain position. And then of course it has grippers, right? So I also have two ports for the grippers. So this is a single device, but it's a rotary gripper. And this came off of an old robot. Kind of a cool little device there. It is from SMC. That's one of the things that I have in my little library. Here's one of the typical cylinders that I showed in the cutaway before. It's got a couple ports here, and you'll notice since there's plugs in the ports, I can't pull this thing out very easily, right? Because air has to escape out of the ports. Here is a small version of the same thing. You can see mounting holes here on the back. You can see the two ports here on the front. If I were to plug one of the ports, then I can't pull this out. But if I let go of the port, then it moves. So plug the port, and it kind of bounces back, let it go. Right, so a lot of times as controls guys, we deal with a lot of programming things and electrical things, but we kind of ignore the pneumatic side of things. And so I just thought I'd cover that a little bit in this webinar. This is the valve bank, let's see, that I was showing you before. There's some of the explanations of this in the book also. These little actuators here, one energizes one of the ports, they're manual actuators, and the other one energizes the other port. So if I take a little probe or something, I can push those and make air come out of the A or the B port, even if I don't have power on the solenoid valve itself. So down here, you can see these are the actual solenoids, right, on the end of the valve. And then this is the manifold where all the air comes out. And this one was on that old machine I was talking about. And I've got blue hoses for extend and white hoses for retract on all those cylinders. So that made it a little bit easier to troubleshoot when I saw my hoses coming into one end or the other of the actuators. It was easier to follow things. And on the cylinder end, I also had labels on that particular machine. Here's a little better look at the solenoid valves themselves. You can see the extend and the retract, right? The A and the B ports of these valves. Let's see what else we got here in the toy box. Most of the stuff's kind of small little cylinders. This one in particular was kind of cool. This was spring loaded and it's a single air port. And so you extend it by putting air here. And when you remove air, it's just a single port, it snaps back. It's actually spring loaded here. And I use these for escapements to drop little balls into a cup. I have a whole bunch of these cylinders left over from that application, with some with fittings in the end, some without. Now here is a 2 port type cylinder that's about the same size as the other one. So I put air in this side and it'll make it extend like that. And I put air in this side and it'll make it retract. So this was an escapement that you would use to drop parts, right? So one would extend, the other one would retract like that. And it took, right, 4 outputs from the PLC to make this operate. So one extend, then switch like that. So all kind of little toys here. I haven't built anything up with this yet, right? I've been in this facility for a couple of years here and haven't built any pneumatic displays, but I'm in the process of building a lot of PLC stuff and electrical components, working on a vision system right now. When I get done with that, I'll probably build something out of these valve banks and actuators just for training purposes. But that is most of what I had to cover today. The reason that I did this at 7 o'clock in the morning, my time, is because I have to drive to Florida today. And it's 1,000 miles. It's a place that I go regularly. I go to Miami and work at a beverage plant, usually for about 2 weeks at a time. And I'm leaving today and need to be in there Monday morning. So I drive because I can carry lots of stuff with me, but it takes 16 to 18 hours to do it. And I take 2 days so that I don't have to drive so long. Sometimes I drive all the way back in 1 day. It's kind of crazy. I'm getting old. That stuff's kind of hard, but in general, anyway, I noticed Samarjit. If you see this later, you may not have been able to make it. I think Samarjit is working, but he attends most of these. Any questions, Matt? Do you have any questions about any of this stuff? It's been a very generic thing. So if you were looking for super detailed pneumatic information, I don't have any of that, right? This is just a good generic information, again, from my book, which is, this is just a method of advertising this book. Basically, I cover all the different parts of it and talk about the fact that people can get into the Automation Academy. Let me see, make sure we got this. There we go. Sure that. We're back here. And I kind of mentioned that at the beginning, that the Automation Academy itself, for all these expensive prices for this book, which I'm sorry, it's a thick book and it costs a lot. You can actually join the Automation Academy for $9.99 a month. And I've seen 2 people at least do that. They just joined for a month, downloaded all these separate documents, and then they have the book for $9.99, which is fine if people don't want to stay at the Automation Academy, but lots and lots of stuff you can download from it. That's basically it. So this is the Automation Academy page, and there's even an Excel spreadsheet in there with all of those documents in them. So this was just a piece of the fluid power section that we covered here today. So the next webinar that I'm going to do, I'm going to cover hydraulics, which is sort of a repeat of the pneumatics. Unfortunately, I don't have any show and tell information for hydraulics. I don't have a hydraulic pump. I don't have, I don't want coolant in this old house that I'm working out of right now and all that kind of stuff. So, but anyway, so that is what I wanted to cover today. And I think we'll just kind of end it here then. Again, next webinar, May 28, 2022, more maintenance and troubleshooting in industrial automation. So more on the book. And thanks, Matt. And Samarjit, if you're there, I can't see you, but Samarjit may be watching too on his phone or something. Thanks for showing up. And I guess until next time.